So this is a continuation of 4.2. You're going to get the notes out for 4.2 polynomials. We've got three more examples. Some of these get a bit tricky, but as I keep saying, try and connect all the concepts together of why we're actually doing these things. Okay, first of all, I've got labeled here example 5. 2x cubed minus x squared minus 13x minus 6. Divide that by x plus 2. So whatever we are dividing by goes on the outside. Remember, we are trying to achieve the first thing that comes in. Hudson, what needs to go up here so that when I times it with an x, it becomes a 2x cubed? There is an x squared there, but what else do we need? Okay, we want to get exactly 2x cubed, so we need a 2 up there as well. These two become 2x cubed. What's our next step, Amy? X as a partner? The 2. So what do I need to do with the 2? Not quite. We need to, if I times this to get that, I also need to times the second thing by that. So therefore that times that, what do I get underneath here? 4x squared. It's positive 4x squared. What is the operation that we always do, Tim, as we go down? Sorry? Minus, correct. 2x cubed take away 2x cubed. Cancels out. And negative 1. Take away plus a 4x squared. What's negative 1? Take away 4. Okay, Gabriel?
5x squared.
5x squared. Positive or negative? Okay. Be careful. Should be a minus. Negative 1, take plus 4. Okay. It's a subtraction. Next step, Maya, what do we need to do next? What do we need to bring down? The next one, we just bring it down as we see it. How do I achieve we're now focused on this guy here. How do I get a negative 5x squared? What do I need to multiply here to an x? Zach? X times something is a negative 5x squared. It's a negative 5x. So this and this is a negative 5x squared. We know it's going to cancel out when we minus. Now what happens next is this has been multiplied by this to get this. And
13x.
13x, not quite. What needs to go under here?
2 times negative 5x.
2 times the negative 5x. Thank you, Charlie.
I was just about to say that, so.
Okay, what's 2 times negative 5x?
Negative 10x.
And negative 10x. Good. Same operation as before. These will cancel out. Negative 13, take 10. Nathan. Negative 13, take 10. 2 negatives, make a. Oh, what was the answer?
Oh, wait.
So cool. Good. Negative 3x. Okay. Next step, Perry. That's it. Hold on. Okay. What question am I going to ask next? Amrita. Do I need a 0x? Not quite. Not quite, that's okay. I'm going to ask x times something is a negative 3. What's missing between these two, Amrita? The 3. What type of 3? A negative 3. X and a negative 3 is a negative 3x. What needs to go here, Emily?
2 times negative 3 so negative 6.
Good, negative 6. These two are exactly the same, which means we are left with a 0. What does that 0 mean? Jesse, what does the 0 mean?
No remainders.
Excellent, Jesse. Remainder 0. There's nothing left over. Okay, so 8 divided by 2, it's 4 exactly. Fits nicely. It's a factor. It's a remainder 0. But 8 divided by 3, how many 3's in 8? There's 2. Remainder 2. It doesn't fit exactly. 4 is a factor simply because there's no remainder. Factors relate it with a 0. If there is a remainder, it's not a factor. Yeah. Hopefully I didn't confuse you too much with that. Now, what does this mean? This means that I can rewrite our equation like this. There's the multiplied out version with everything, there's no brackets, but then I can get it into a version where there's brackets involved. It's just like saying, if this was 8, I can re-express 8 as 2 times 4. But we're doing it with equations. Any questions with that? Okay. And when we get things into brackets, when we get our equations into brackets, what is starting to slowly reveal themselves? What's being revealed? Zach, what did you say? Because I'm going to give a lolly for it. X-intercepts. Okay. It's X-intercepts.
Wait, is polynomial still about graphing?
Yeah. Yes, so unfortunately. Unfortunately. All right, next one. Second last example for today. That was the first one. This is the third last. Next one. This, as a warning, might do your head in a bit. Why? There's a 3x, and that 3, if we're trying to relate it to a 2, does it fit in nicely? Not quite. So we have to think about certain things. We're trying to turn a 3 into a 2 because we want a 2 in here. What am I going to multiply the 3 so that it changes into a 2? Okay.
2 on 3.
2 on 3. The 3's are going to cancel out. The 2 remains to get the 2. So now you're dealing with fractions. Okay. So if I wanted to execute here, how many x's to the power of do I need to get to an x cubed first? X what? As before, it's still squared. Thank you for that. But we're going to multiply it now by 2 and 3, which creates a lot of work. 3 times a 2 and a 3 is a 2, as we've got there. Therefore, what is in here, Charlie?
I just got it.
Charlie, 2 times 2. 4. A positive and a positive. You're going to have a nice fun time doing fractions in this one here. First one, 2 and a 2 cancel out. -9, take away 4 on 3. -9, take away 4 on 3. What is that?
7 2/3.
7 2/3. Okay. Let's do it. -9, take away 4 on 3. That's what we're doing in our head. Back to year 7 and 8, fractions and denominators. What do I need in here? I want the same denominator of a 3. What's something divided by 3 is a 9? Three times 9 is? 27. 27 divided by 3 is a 9. I can now add. We do the cross multiply. That's over 1. 27 take away 4. -27 take away 4 is how many thirds?
23. Oh, never mind. 31.
Figure 31. Good try though.
Yeah, I didn't say the negative at first.
That's okay. Same rules apply. Hudson, what do I need to do next? I forgot that.
Write down 11.
Good. Okay. We are now targeting this 3 times something is a -31 on 3.
-31 over 9.
And -31 on 9. And the way we can do that, as Tim, it's simply also with basic algebra. Question mark opposite of timesing is dividing, putting the 3 on the bottom, -31 on 9. What needs to go with that number? An x. Okay. We now know that the 3 and this gives us what we want. 2 is being left out. What's our answer if I multiply this and this, Maya? 2 times the -31 on 9. And -62 on 9. Okay. We subtract once again. That looks complicated, but they're exactly the same thing. Cancel out. -11, take 62 on 9. Two negatives make a positive. I want the same denominator now. I've got a whole number and a fraction. What am I going to multiply the 11 by, Jesse? Good. It's a cross multiplication. 99 take away 62.
That's
Is that not right? What did I do wrong?
You can blink it. It should be 62 take 99. 62 on 9 take 99. Because they're like.
Oh yeah, thank you. Excellent. Thanks, guys. Thank you for that. Yeah, like. Okay. Negative 9 take away. Negative 9 to 9 plus 62 should be negative 37. Should have that. Not very nice numbers to deal with. So here, negative 37 on 9 comes here. Where am I up to? Right there. Bring down the 30. Okay. One more to go. 3 times what is it negative 37 on 9? Okay. We do it the same way as we've been doing it. We're just going to fast forward with that. Two groups of a 37 on 27. So negative 74 on 27. It's a lot of work. Lastly, we're now working out 30. Take 74 on 27. 184 on 27. 884. Yes, correct. Hold on. Do you do that in your head? Very good, Tim. Okay, I'm going to do it on paper. 30, take 74 and 27. It's a plus. We want over 27s. 27 times 30. 20 times a 30 is 600. Plus 210 is 810. Did I get that right?
It's not a plus.
That should be a plus. Thank you. You pick that up. Okay. 884 on 27. Yes, sir.
And negative 74 on 27 squared for 100 pence.
This one here? No.
The top one.
Ah. Thank you. Thank you. Thanks, man. Tim, I'll give you one because you can do those calculations in your head. Okay. It's very messy. Very messy work. The last one is a quick one. Any questions with this? Okay. One more to go, and I'll stop talking.
So,
Yeah.
for this topic, will we be allowed calculators and tests?
You should be. I'll double check. So this one looks pretty straightforward, but it isn't. But it's nice and quick though. You can see here now that we were dividing things like x's and ones, etc. The difference in the power, this one's a power of 1. What's the 1? It's a power of 0. Okay, because x to the power of 0 is 1, and you're left with the number. But sometimes you're being asked to divide with one thing, but the difference between them is 2 powers. x2, this is x0. So we have to make room for what's in between. And what's missing in between these two sets of powers? X to the power of 1. We're missing an x. So what I'm trying to say here, instead of doing this, we need to make room. X squared. We need to divide by this now. A 3 term. We're dividing by 3 terms with a 0 in the middle. And we only do this when there's a jump in power in what we're dividing by between the 2 terms. Or we just keep going as before. What number needs to go? We wanted 2x cubed in here. But what are we multiplying by? With the x squared. X squared times something is 2x cubed.
Right.
And it's 2x squared. Yeah. Just a 2x, thank you again. Okay. And then what happens now is this gets applied to each of these. Okay. 2x times 0x is? A 0x squared. Doesn't matter if it's positive or negative, because 0 is neither. And then a 2x times a 1 is a 2x. So when we minus, we're doing it in a group of 3. Cancel. -1, take away nothing, is itself, because 0 doesn't change it. 3 take away 2 is a positive x. Okay. And as we've been doing before we move on to the next thing, what needs to happen?
Plus sign next to 0 squared.
A plus? Oh, it doesn't really matter because 0. Oh, thank you. Thank you. Yes. Thanks. Do another lolly. Okay. Pull the 2 down. Thank you, Charlie. Was that you? Yeah. Now sharing them around. Okay. 3 take away 2 is a 1x. Just going to highlight that. Lastly, x squared times something is a negative x squared. It's a -1. Thank you very much. A -1. And we apply that -1 to each of these. -1 times 0x is just going to be a 0x. You've got to keep counting it as if it's still there. And a 1 times a -1 is a -1. Okay. We are left with cancel. 1 take away 0 is just the 1x there. What's the last number? It's a 3. 2 minus 1 is a 3. What does that mean? We've answered it, but what we are saying that we can change this equation between x squared plus 1 as a factor, then this one here, then a 2x minus 1 as well. But what do we need to attach at the end? we have our remainder, which is x plus 3. But if you don't want to write it with the letter r, we simply add our x plus 3 over what we divided by. That's another way to rewrite it. Do people get that last bit? Hands up if that makes sense to you. Okay, hands up if you want that re-explained. Okay.
Did anyone else have their hand up, sir?
No.
Oh,
I'll do it for you.
That's fine. I'll figure it out.
Now I'm gonna do it. I'll just talk to Zaid. If anyone else wants to tune in, no? Okay. 8 divided by 3. 2, remainder, 2. Okay. But that's just like saying 2 and the 2's on top over the 3 that we divided by. 2 remainder 2 is really 2 and 2/3. You're rewriting the remainder as part of what you divided by. Okay. Okay. But we're just doing it with equations. Any questions? Okay, you get the 4.2 notes now. For the rest of our double,